Okay, once again, when you are taking a derivative, you are finding a slope of a tangent line to a curve. If you're asked to find the equation of a tangent line to a curve at a point, then what you're asked to do is this. Find y equals m, x minus x naught plus y naught. Where here's my x naught, here's my y naught, and if I need to find m, it is the derivative. Well, y there is a quotient. So remind yourself of the quotient rule. So if I have f over g and I want the derivative, please try from memory to write it again, the quotient rule. Okay, check your work. If the quotient rule you wish to know, it's low, d high, less high, d low, draw a line, and down below denominator squared will go. Okay, so using that definition then, we want the slope, and we need to evaluate this slope when x is equal to 1. So what do we want? We want to find the derivative of this function. What's the derivative? Using the quotient rule. It's low, d high, less high, d low. Draw a line, and down below denominator squared will go. And I promise not to recite that again. Okay, simplifying this then, look at the top, you've got a GCF of e to the x. Pull it out. You're left with 1 plus x squared minus 2x all over 1 plus x squared all squared. We wanted to evaluate this when x is equal to 1. So if x is equal to 1, I've got e to the power of 1 times 1 plus 1 squared minus 2 times 1 all over 1 plus 1 squared all squared. Oh, what happens here on the top? 0 times e to the 1 over 2 squared. The answer to this is 0. That's telling me that the tangent line to the curve of this function at this point is horizontal. What's the equation of that line? Well, if we take this and write y equals m times x minus x naught plus y naught, it's just going to simplify to y equals e over 2. So there's the equation of the tangent line to this curve at this point. What do you observe about this? It is a constant function. Because of course e isn't a variable, e is a number. So here's a summary of the formulas and derivatives that you know. You are expected to know these. We'll get them on a card, a recipe card, and you can have a little recipe for success. So let me just talk these through. The first one is just telling us that the derivative of a constant is 0. Of course it is. The derivative is the slope of a tangent line to a curve at a point, and a constant function has always the slope of 0. Here's your power rule. The derivative of x to the n is nx to the n minus 1. Have a close look at this. It only applies to power functions. It's the first one you learned, and I find people tend to overuse it. The derivative of e to the x is e to the x. It's not x e to the x minus 1. So don't try to force everything into this form. This only works for a polynomial function or a power function. If you have a constant times a function, you want the derivative, pull the constant out. If you have a sum, take the derivative separately, same as when you're subtracting. When you're multiplying, you need the product rule. When you are dividing, you need the quotient rule. So here's your assignment, and we did about half of it yesterday. I'd like you to finish this. And I'm hoping we can get most of that done in class.